TMA presents Manufacturing Day 2020 Tour, a live look at OTTO Engineering in Carpentersville, Illinois.
Good morning. My name is John Lang. I'm the manager of the Tech Center. And this Tech Center was built to take care of young people so they can get started in a career. And we also manufacture parts for our switch division and communication division. And to start with, we're going to look at the CMM. That's an inspection process that we have. And Joel is right now checking one of the parts that we're running out on the machine. Good morning.
What's your name?
My name is Joel Waters. I'm the CMM program here at OTTO Engineering. What I do is they use CAD models to machine their parts, CAD models, computer design, and I take the same CAD model and I take the same CAD model and I use it to inspect those parts. Basically, I program the part using the CAD model. So if the part's not correct, I will know about it. I'm able to inspect parts within 50 million of a inch. We use the roller trucks. All our parts are centrally located in a general area, so it makes it easier for optimizing our programs and for other operators to run the machine as well. We'll take pictures of our setups, so every operator just come over and utilize the pictures and set the parts straight up and just push a button and it will start. As you see right now, it changes. We have different styles, different sizes. We have small as 0.5 up to 3.5 millimeters in diameter balls. We have a calibration sphere there. Each whole stylus is calibrated once a week or during programming if there's an issue. But every week we definitely program every stylus there for the master sphere, calibration sphere.
What are these parts going to be used for?
This is Orion. This is going to be used in space. It's going to the moon.
What kind of education did you have to have to be able to do this?
Actually, OTTO Engineering sent me to ZEISS training facility approximately 11 years ago. Did my basic math, and then every year the computer's calibrated, new software gets updated, and you get familiar with new software. So I've been doing so much work.
Anything more?
We're going to go out to the machine that's making this part next. This is Carl Ratke. Carl Ratke is in charge of this whole department, but he also runs the 5-axis mill that we do. And right now, the part that we just inspected over there, Carl is responsible for running and make sure all the dimensions are 100%.
This is for the Orion project?
The Orion project, right. And the Orion project, these are some of the switches that we have. And here is pictures of where they go inside the spaceship. And as you can see, there's a lot of switches in there. They all have to work 100% all the time because they're really a long ways away from home. And here's another picture, a little up closer, to show you that this truly is going to go to Mars one day. This is the piece part that he's machining. He pretty much does most of it in one operation. And here's some examples of some of those switches. Now, one of the things that we said is that we have 5 axes of motion on the machine. Most mills only have 3. So why would we want 5 axes of motion? Sometimes we have parts that are pretty complex and would have lots of operations. Everything you see that's there is done in one operation. So the only thing we have to do is separate that from the material, and then you have this part
and we only have one little area we have to mill. So that's really done in 2 quick operations, but everything is very close tolerance, the thickness of a hair, and it's done relatively, 99% of it is done in one operation. It's movement of machine, and that's what we like. There's not a lot of fixturing. And here's another example of the same type of thing. We do all of that work in one operation, and then we just blow the material off the back and it's done. So that's some of the advantages to 5-axis machines. When you talk to Lou down there, you're going to see that he's making this part while I'm making this part. Well, they go together. Fit right in there like that. And there's several different pieces that will finally end up in this switch.
Thank you.
You bet. Now we're going to come over here and talk to a few other people. And we're going to talk about how they became a graduate of the Tooling and Manufacturing Association and where they came from and what they're doing here right now. The first one is Eduardo. Eduardo was part of our, come on over here. Eduardo was part of our work program. He went to school in Dundee. And I'll let you tell your story as to how you got to be a setup person here at our.
All right. Like you said, I took a work program at Dundee from high school. They gave me the opportunity to come here and work right after I graduated. And I worked for a year on the production line. And luckily, I got promoted to come down here to the machine shop. And I did cleaning for about a year. And then I got promoted to an operator. And then when I got promoted, I also started my first year at TMA. And with progress, I got the opportunity to become a setup. And that helped out a lot. Learning things at TMA and being able to use it at work, it all came together. It's been successful so far.
Can I ask a question, Eduardo? How much then did you have from all the schooling that took place for you to get where you are today?
Good amount, at least 10.
Who paid for it?
Auto engineering.
Everything was paid. There's zero debt. So that's one advantage we have to working with a program like the Tooling and Manufacturing Association. And sometimes kids go to a high school that has a very nice program in machining. Eduardo didn't have that opportunity. But there's other schools in the area that have it, and they can get going a little bit quicker. So that's one thing I'll say to the teachers of school. You really need those shop classes. The next person here is James. James, tell them how you started here at OTTO.
I started here from the line. So I worked on the line for 7 years. And there was an opening down here for second shift. So I tried it out and enjoyed it. And progressed from the second shift and came to the first shift. And got a little bit more experience down there. And then I was like the guinea pig for TMA. And they tried me in a few classes there, which worked out very well. And got me better knowledge of what I was doing on the machine. And then they did another 3-year program, and I was in there also. And it helped my progression a lot to get me to where I'm currently at as a setup. And I had a good time at school.
All right, we have another person. Thank you, James. OTTO is very proud of this first graduating class. Some of them are in CNC machines. That's Eduardo and James. And now we're going to talk to someone who's in tool and die who did go through a high school program. So let's this is Kristen. And Kristen is also in our first graduating class of apprentices. And tell us your route and how you got there.
So I first started doing program at a school called manufacturing. And from there, that's when everything over and that's how we recruited the starting program. And then I went to 3 years called TMA.
And he's on his way to being a tool and die maker. And he's very talented. We're very proud of him. He's a good person and learning a trade. And again, he has zero debt. He's going to be very high up on the wage scale here at OTTO in a short period of time, and he's just going to continually do better. And that's part of the ability of going through a program. And the Tooling and Manufacturing Association has done a great job of training these kids. Thank you. Now let's go to one more machine, and I'll be as quick as we can. It's the making parts system. One more comment that I'd like to make on the walk over there is he's taking pictures of the building, and you notice how clean it is. People think of manufacturing as being dirty. There's nothing dirty in this building. This is cleaner than most offices. It's well lit. We have great inspection equipment. We have the greatest equipment that's available. And that's why we can do the work that we do. But this is a great field, and this is Blue Step, and he was making the mating part to the Orion and kind of show them how you had to inspect it and cut one in half and the close critical dimensions and so forth. You may have seen this piece earlier over there with Carl, but this plunger for this switch has to be made in different stages. Originally, it's turned round. Modern? Originally, it's turned round. And that's me next in this condition. And then what I first do with it is I make a nice square so I can hold on to it, which is part of the dimensions of the print. And then from there, we actually change it into a plunger type switch. You can see the features. And for inspection purposes, we have two ways. We have to have it done on the CMM, which is the coordinate measuring machine, which you probably saw earlier. And also, I physically have to cut the part in half to check the internal features. Show the profiles. So, this is the only way for us to see the groove that's on the inside and some of the features that are not visible from, the CMM or from just looking at the part. The holes on the top are too small to get regular standard tooling in there to check it. So your instruments won't work, so we physically have to cut it in half and go to a comparator or an optical comparator and have it physically checked that way. And how do you know the rest of the parts are good? Is it the positioning and the accuracy of the machine? Oh, absolutely. The machine is very accurate as long as we make a very, let's call it a structured setup. It's going to be, repeatability is going to be fantastic within a tenth or two. So as long as we totally load it the same way and check it the same way, we can keep control of everything. Real quick, show them the grip part that we've made in the past. This is a raw casting that we machine. Now we're not a foundry, so we don't make the casting, but we do make the features that we need. All the holes that you see in there have been machined on the station right here. It has a lot of different little holes that you see all tapped in and machined in, and even interior over here. What we do is we take it and we put all our switches, we populate them. We have base plates that have the switches. This is for a military helicopter. It is called the mission grip, and it controls all sorts of things. Sometimes the crane, sometimes it's the gunnery system. But it's whatever they want, we'll populate it with the switches that entail exactly what they want. Thank you, Luke. Thank you. Really take a good picture of this right here. Right there, because that shows that they use the CAD model. Isn't that awesome? All right, we're kind of skeptical. The first thing we do on this part is actually probe the part to repeat its position all the time. I can leave the door open and show you how we find the center of each individual part. This is going up in space, so we have to make sure that it's accurate. The probe is actually finding the center of the part, so I know that everything is perfect. We got to shut the door now. The next area we're going into is our wire EDM department. We have Mitsubishi machines. They're very precision, and it's a very important part of building dies. I better right through this door. This is Ralph. I was explaining that this is the wire EDM department and explain why it's so important in die making.
There's advantage of this department. We can talk with the electric discharge machine, which means we use electricity to burn to the hard material. Material is already hard, so it's hard to get this with the conventional tools like a drill and everything that we use for soft materials. Most of the cases we use on a hard material. But if you look at the table, I can give you some examples. These materials came from they already hard. We also can cut the soft materials, but the advantage is to cut the parts, whatever the parts are, out of hard metal. And we use the wire, which is discharging electric current through the block and shooting away those materials.
And what diameter is the brass that you're using?
Mainly, we use the 10,000 wire, and the other one that's over here. This is a 6,000 wire. You can also use a 4,000 wire, which is like the thickness of your hair. So we use the wires to cut the elements, small details like this. This is a gear. That's one of the examples.
And how thick can you go through? What the hardened material? How thick?
This is in this case we're cutting about 10 inches, 11
You
inches.
can have 10 inches thick, totally hardened metal,
Yes.
and you can make very precision cuts
Yes.
just using a 10,000 wire.
Yes, we can, but we have to take a couple more cuts. Not only one cut. We use the one rough cut and three finishing cuts or four finishing cuts. Depends what surface finish is required. We can cut even thicker material on those issues. Those are the newer machines, new generation Mitsubishi machines. They go a little bit higher than that, 12 inches. So material is like this. Can you imagine this spark? Whenever you go, it's pretty much like welding. If you control that gap between the wire and a spark is going on the other side to the material. So that's what we do. In this case over here, we're cutting the insert. This is the opening over here, and on the outside it goes into another element. If I can show you what we do, we get back to this. Okay. This is fully hard material over here, and this is the opening that we cut in the material. This is the wire that travels, travels over here through the guides and goes on the back, but the wire travels this way like this, and it cuts a required shape. To cut the taper, you can just kind of tilt the wire in so many different ways. So this is a good example. I hope that explains.
Ralph, that was awesome. Thank you. This is the opportunity model production. Thomas, the supervisor. Good morning, how are you? He's going to real quick show us the basics of the die at the tool maker.
So basically the way we start our operation out is we'll get a design from our engineering department. Okay, so they want us to create this part. So from there, we go into design. We design a whole strip layout, and then we design our die. And then we break it down into smaller components. So every one of our dies has a folder that has just all the drawings are broken down into sections. Okay? So that being said, we start out with a chunk of steel like this. Okay? And then we turn it into a chunk of steel that looks like that. That being called a progressive die because as we start with just a regular strip of brass that looks like this, as it goes through the tool, we cut out, we notch, we form, and then we cut the basic part out to make a part that's like this. This particular die does also in-die tapping as well as silver insertion to form the contact on the part. So we're responsible for all the creating of this and the quality. We build and maintain our dies for production for the main company. So we run about 40 million parts a year with less than a 0.5% reject rate. So we're pretty proud of that because we can change these things over maybe 10 times a week and our repeatability is spot on. So that's what we're looking for is the consistency that we can change them back and forth. And in our opinion, that's what makes a Class A die is how good it runs and how easy it is to maintain.
What would this be used for, this part?
Well, I don't have the exact part for that. So in here we have a cutaway where you can kind of see where the parts go. So these are how our switches are created. This is a better example. So we make all the metal stampings that go into this part. I think the only thing we don't make is that spring in this roller.
And where would they go?
This is used in a locomotive. So it's sold to GE and then they put them on locomotives. I don't know exactly where it's used, but it has something to do.
Yeah.
So when you operate it, you can see how what we call the butterflies, they're actually terminals, but they'll flip back and forth to either make contact up here or down here. So it's kind of a unique switch, and it has a bunch of different components that go in it, you know. But we manufacture almost 95% of that. So
Switches is your specialty, right?
that's what the company is big into is switches. We also do audio stuff. We ourselves do some of the audio, but a lot of our switches are they're high end, so they go into aircraft and space shuttles and stuff that you're not necessarily gonna find in your car. We don't do wall light switches, So it's the stuff we depend on working. When the pilot hits the button, that landing gear has to come down. Okay. Thank you.
Great job, Tom.
All right.
Tommy? Now, one of the things that Tom said is that the tool maker is in charge of these parts and the quality of the parts. It's all tool related. So he has to design the tool. He has to make the tool. He has to do everything there is. He has to troubleshoot it.
so that everything is 100% every single time. Now Tom's in charge of the press room. Come on, Sam, let's walk into the press room. The part that we're going to go look at in the brewer, how many of those do you make? We make about 60 different styles. We've got single form of silver on one side, another single form of silver on the inside that we contact for switch, and then we have one with a double form where there's silver on both sides. So we run about 30 million parts a year. We'll take a look over here. We bought this press about a year ago, and it's running at 300 strokes a minute. So what that means, every time that ram on the press goes up and down, every minute we get 300 parts coming out of the die. And here's what the parts look like. If you look at this side here, this is where the silver is. We use a lot of silver because we make electrical switches, and silver is a great conductor. Come over here, I'll show you the material. This is the material that goes to the progressive die. The yellowish colored metal is brass. This is called the silver. It's called silver inlet. Basically what they do is they take the brass and the manufacturer of the material embed basically with pressure the silver into the strip. And that way when we run the material through the die, we get on that form the silver that makes contact in the switch. Look at one more. We'll walk out towards the big tool room now and look at that press. We only have about 4 minutes. There's all sorts of different types of materials. This happens to be a copper part. We're just in the process of setting it up right now.
This is one of your younger students.
This is a graduate from South Elton, and he is in his second year of TMA.
One of the things we have to do, this is all the materials for all our different parts, and we also have to look at the scrap and we recover it because there's a lot of money in this. Something like stainless steel isn't that valuable, but when we fill this up with brass, brass with silver inlet, it's very valuable. We got beryllium copper over here. That's very expensive, and we use that as part of our cost roll-up. This is all copper here. As you can see, there's quite a bit of copper in there. When we fill that up, there's a lot of money there. But there is no scrap.
How many people are working here now?
We have at OTTO about 550 people. In this building, just for the manufacturing of parts, we have about 70. Now, we also do dies for other companies. We were a little bit afraid that the die industry is dying, and we decided that we're going to buy a company and we're going to make tools for other people
because there's not a lot of people building these progressive dies anymore. But to do that, if you see the press over here, it's much larger. And the reason it's larger is we have the ability to do small dies like for OTTO, but we also have the ability to do big dies that might end up in a Ford car or in a Chevy car. And the object is to make the tool. We're not going to run it. We're just going to try it out, and then we deliver it to the customer. So we want to be one of the last people standing when it comes to die making. And we think we're going to be very successful. We don't want to stamp for other people. We only staff internally. We have no desire to do staffing for other companies. But as you see, even this area is very clean. It's very neat. It's organized. It's well lit. And the building was made a year ago, and it looks just as good today as it did when we entered here. And people don't realize that working in this field is a little bit more like working for with computers, and in dealing with the computers, it's more like a video game, and it's fun. And there's lots of interesting things we do to make the parts the way we do. Okay? Are we just about done?
We're done.
Well, thank you for coming to OTTO Engineering and doing a virtual tour. This is my first, so normally we have lots of kids coming through here, and this is one way to do it and be safe. Thank you.